now called the Pria, which is a private intelligent assistant. This is joint work with Niranjan at Stony Brook, Supriyo at IBM Research, and graduate students Shashank Jain and Vivek Tiwari. And I should mention that Shashank was the main architect of this project. He did a lot of the implementation. But both Shashank and Vivek are master students. They've left. And when I asked them, they had zero interest in coming and giving the talk here. And so here I am. All right. So the intelligent assistant landscape today is pretty big. So an intelligent assistant is a software that basically helps you do tasks, right? And a subset of these are called personalized intelligent assistants. So these would help you do tasks using your personal data according to your personal preference. You might have heard of many of these. For example, Microsoft's Cortana, it would help you, for example, tell you that you're late for your flight. It might give you the shortest route to the flight without you having to ask this question. Right? It would give this automatically just based on your email. Google's news suggestion would suggest news articles that might be relevant to you. There's the Amazon Echo. There's many of these. But so the way these work is that the personalization happens in the cloud. These cloud services would track your clicks, your emails, your browsing habits, and then they will build models about you and then tell you something that's useful to you. So this means that clearly the problem is that personalization costs privacy. So the vision, the long-term vision for Pria is, can I perform personalization completely locally? By local, I mean on my personal device, maybe my laptop, maybe my mobile phone, on a private cloud, what have you, but under my trust zone. And the reason why this could be interesting is the good, that is that personal devices today are pretty powerful. Our laptops and our mobile phones are getting more and more powerful. Of course, the bad and the ugly is that it's actually not completely clear what kinds of IA services you can support locally. You might actually not be able to support a service at all locally because it needs cloud interaction to begin with. Now, even if you do have a set of services that you can support locally, there are many questions that need to be answered, right? Can you guarantee privacy? So can you make sure that you're not leaking any information to this cloud service? Can we run your required algorithm on your laptops efficiently or even your mobile phones efficiently so that it actually makes sense? Will the performance that you get in the end be comparable to what you could get when you're running this on the cloud services? And I don't have the answers to these questions. This is, I think, a really long-term direction. But what we did do in this space is we took one example IA service. In this case, it's a personalized news recommendation. And we figured out if we can do these things. Like, we can actually run them completely locally. So that's actually what I'm going to be talking about today. And then maybe some lessons learned on and how to proceed for other kinds of IA services that we may want to support also totally locally. All right, so let's first look at what one of these personalized news recommendations would look like. The way it looks is that there is an aggregation site, and a popular example is Google News. And then it actually aggregates data from various sources, like from CNN, from Washington Post, from the failing New York Times, and many others. And then what a user does is she logs in to the service, and then she starts reading articles. And the service keeps track of what articles you read. And then this would then start giving you personalized recommendations, right? And the important thing here is that you have to log in to get the service. If you don't log in, you can still read the news, but you won't get personalized recommendations. So this is sort of a binary proposition. Either you log in and they can track you and they'll personalize, or you get nothing. Right? So this is what we want to do, is to see if you can actually provide this personalization without having to log in to the service. But before I start talking about that, let me quickly go over what our threat model is. So the adversary, according to us, is any of these aggregation sites that will personalize articles for logged in users, but they will provide non-personalized service if you don't log in, right? Or it could even be an individual site that you have to log in for personalization, If you don't log in, you can still read the article, but you cannot get any personalized service. And specifically, what's not an adversary in our model is just individual news sites that you can go and read news from, for example, CNN. Right? And of course, one could argue that, well, CNN can still track me, they can do fingerprinting, but we're assuming that you could do some things to not be fingerprinted. I mean, you could use Tor, you can use a do not track extension, and so on. And the main distinction here is that in the case of the latter case, I can still get the service. That is, I can read the news without having to log in. Whereas in the former case, the service that I want, which is personalization, I cannot get if I don't log in. So I can't use do not track and still be able to get a personalized news recommendation. Right? So that's the rationale for our threat model. So given this threat model and given the fact that we want to do news recommendation locally, so the key idea in PRIA, which stands for Private Intelligent Assistant, is that we want to decouple aggregation from personalization. Okay, so what I mean by that is that let's assume that there's some aggregation service that gives me all the news articles. I'm going to do personalization locally on my device, let's say my laptop. I'll build a local user profile using data that's locally available. In our case, we use the browser history, your Facebook and Twitter feed. And then you would download all of the news. So I'm punting here. Let's assume that you can download all the news articles from the aggregation site. And then you use your user profile to rank these articles based on the user profile to figure out what's most interesting to the user. And then you would send this recommended news articles to the user. So this is the basic idea, right? So before I go into how you would do this, there is a clear trade-off that PRIA faces, right? Which is that it does not have information about the population at large. So if you look at most of these learning algorithms that work, the way they work is that they collect information about me, they collect information about everybody else, and then collectively they're able to make decisions about what I like and what I don't like. For example, my colleague at Stony Brook might like this specific Chinese restaurant, and then based on the fact that I work in the same building and I live in the same area, the service might suggest that I also go to this Chinese restaurant, right? But that's not an information that we have with PRIA. We only have information about what I did, not about what the rest of them did. So you cannot use techniques like collaborative filtering. But on the other hand, what PRIA does have is has more information about myself. For example, I can now use I can use my Facebook feeds, my Twitter, and my Click and whatnot, whereas the cloud service only has information about how I interact with that particular service. For example, Facebook would have information about how I interact with Facebook. Google would have information about how I interact with Google products, but that's about it. And so really the question here is that I'm losing information because I don't know about the population at large, but I'm gaining information because I know more data about myself. And so the question is the gain going to compensate for the loss? So that's the question that we're interested in. Right? So, and it's not only this question that's interesting, but it also drives how we can do our design, right? Because usually, if you look at existing news recommendation systems, a very, very common technique is to use click-based collaborative filtering. In fact, if you were at the poster session yesterday, Morgan showed that you could use click-based collaborative filtering to recommend articles to reservation areas because you can collect this information, right? But that's not something we have. So we only have local data, so we can't use this kind of collaborative techniques. The other way to do news recommendation is use content-based approaches where you look at the article that a user is interested in and look at all the words that occur in the article and then model what I'm interested in. So this is usually called bag of words, which is actually a promising technique. One issue with bag of words is that it's too fine-grained. So this means that you need a lot of data to represent an article because you have every single word that occurs in the article. So what we do is we use this content-based approach, obviously because we can't use click-based approach. But then we extract some high-level semantics about what's in the page. So for example, we extract the entities and the topics to represent an article. And by the way, this is not a novel technique. This just happens to work in our scenario. And so the entity would be the organizations that occur in your article, the names and people. If you read an article about tennis and there's Roger Federer in there, then that would be an entity. And topics are just topics. So sports, for example, would be the topic. And then we build a user profile graph, which basically connects the articles to the entities and the topics. And so because entities and topics are higher level abstractions than bag of words, it's actually a much more manageable set that we have, that we can actually easily build on a laptop. So this is what a user profile graph would look like on a laptop. You have news articles, you have Twitter feeds and Facebook feeds. We would first extract topics from all of these. We use this technique called LDAs, latent directory allocation. I know nothing about it except that we can use LDAs to get topics. And then, then you also extract entities. And here again, we use a standard technique called Stanford Name Entity Tagger, which gives me the set of entities. I connect the articles to the topics and entities, and I have my user profile. And I have to mention that we actually did no contribution in these techniques. We used them as is. In fact, we used them as is on the laptop, and they work just fine. The only thing that we had to be careful about is that we have to do aggressive pruning so that these graphs don't become really big, because obviously in a cloud provider, you can have a huge graph and analyze it. On a laptop, you want it to be much smaller. Okay, so now we have this graph. We want to figure out how to, and I keep connecting this algorithm. I keep updating my graph. I need to figure out how to now recommend articles. The way we do that is that we have the user profile graph, and then remember that we assume that there was an aggregation site from which we can download these articles, which is what we do. We have these candidate news articles. And then basically we do the same trick. From each of these articles, we figure out the topics and entities, and then we connect them again to the user profile graph. And then we run a personalized page rank algorithm that tells me how important each of these candidate articles are based on the distance sort of roughly to the rest of the user profile graph. And then that would give me, and I would rank it according to these scores, and the one that's most relevant would be ranked high. And then we just present these two. Right, so just to put it together, we have this Google News aggregation, which aggregates news articles from various sources. Pria works on, the news recommendation, Pria works on the user's laptop and their phone. The laptop runs the personalization algorithm. The phone just first collects user activities and sends it to the laptop. Then the personalization would request news data, and it would get, right now it actually would get all of the data that's there on Google News. It would personalize it and then send recommended articles to the app. Right? And our app itself looks like this. So it's basically, there are two tabs, and I'll come to that in a bit. But it gives you articles that it's recommended, and you have to swipe right if you like it, swipe left if you don't, which I heard is the standard way to do it on smartphones these days. And also you can click on it if you want to actually read the article. And what we ask the users to do is to click, they say that they like the article if that's something that's a recommended news item that they want to actually read. And there are two tabs, because we actually have one tab showing Priya's news recommendation and another tab showing Google suggested news. So obviously, if you want to do Google suggested news, you have to log in, and you would get this news. But I want to mention that when we do Priya's personalization and we download the aggregated articles, we make sure that there's no personalization there. It's just the news that there is. And of course, we also randomly change the tab so that we don't show the same thing on the same tab, and so on. Okay, so some quick implementation details. The personalization is done on a Mac. We download about 40 to 50 news articles from Google News and send 10 recommended articles to the app from both. And then the app on the mobile phone would just collect user feedback on which articles that the user thought was relevant and which was not. And I want to mention something important here, which is that we as researchers do not actually see the user profile. We do not see the articles that are recommended to the user. We see nothing. what we see is that on tab 1, the user liked articles 1, 3, and 5, and on tab 2, they liked 3 and 7. That's the extent of our feedback. So we conducted a user study. It has 6 users, and the study was for 10 days. By 10 days, I mean that we got feedback for 10 days. So we actually, the app was running for slightly longer than 10 days, so we can collect enough data. This is an IRB-approved study. The users rated about 200 articles. They found about 750 of them to be relevant. There were 2 main goals for our study. First, we wanted to show the feasibility that Pria can efficiently run on a laptop. I'm not going to talk about that. But the other goal was to compare Pria and Google's new study. So here is just a comparison on one metric. There are other metrics we looked at. So in this metric, we look at this precision at 10, which means that out of the top 10 recommended articles, how many of them were relevant to the user. So here you see that Google suggested news has 0.45, which means 45% of the articles people thought were relevant. With Pria, it was 0.38, which is 38%. So this is a little bit of a weird graph because I'm actually proclaiming that what we did wasn't the best and Google did better, but of course, you'd be surprised if it was not true. But for me, the main takeaway is that, well, doing this recommendation locally is worse, but not that much. And in fact, maybe we can even tune our system a little bit more to make it better. All right. And so I take this as a positive sign for being able to provide an alternative to a privacy-conscious user so that they can actually get this service without having to log in. So let's quickly revisit the questions we had, which was what kinds of IA services can we support? And so for this specific news recommendation, we show that you can actually support it and guarantee privacy for the threat model we have and run on the device and have performance comparable to the cloud. But what else can we do? So this is my last slide. So we have a few ideas. For example, I think that you can actually maybe personalize over any kind of public data that's available that you can aggregate and download and do the personalization locally. For example, you could do event recommendation. You could actually do recommendation for the kinds of things that Morgan was talking about yesterday at the poster, which is recommend articles for reservation. You can also personalize over your private data. For example, if I have my emails and I want to do some question answering, I could do that because I can do this locally, right? Of course, we can do all of this. The questions are, can privacy be guaranteed? This is slightly tricky for other cases, I think, because in this specific instantiation, we assume that you have an aggregation site and I just simply download everything. That may not be possible for all applications. You could not have an aggregation site at all, which means that you have to interact with the cloud to get the data you want in the first place. Or you have an aggregation site, but you can't download everything. You can only download a subset. So these will raise interesting privacy questions. Can we run the required algorithm on personal devices? Well, certain devices, for certain things on the laptops, you could, but for certain applications, you may have to run these on your mobile device, which makes the constraint a bit more. And will the performance be comparable to the cloud? So there's lots of questions here. And I think that this idea of doing local personalization has some promise, but of course, there's a lot to be done in this space. Thank you for your time.